Chapter 5.1 Nth Root and Rational Exponents. Definition of a rational exponent. The nth root of a can be represented as a radical symbol a, and in the cap you have n, so nth root of a. And in exponent form you can write it a in the bracket, and on the top you have exponent as 1 over n, where n is going to be the index and a is the radicand. So the number that is inside the radical symbol is called radicand. Now we are going to do example number 3, approximating expressions with rational exponent. Evaluate each expression with the use of calculator. Round your answer to 2 decimal places. So we're going to use 9 to the power 1 over 5. So there are many different calculators we can use to find the answer. So if you're using a simple calculator which has this button, is used for power. So 9 to the power and bracket open, 1 divided by 5 bracket close will give you the answer, and that's going to be 1.55. Another use of calculator, you can use it 9, press the 9, and then in some calculator you used to press the button second, so second, and then this, so press this button and then press this button, y to the power x, which means that you're taking 9 here and x is the power. And what is the power here is 1 over 5. So you write the bracket 1 over 5. And that give you the answer. So 12, you press the button, this one, to the power 3 divided by 8. Using calculator, you're going to get the answer, approximate answer 2.50. Again, so this one is going to be 7 to the power 3 over 4. You're going to press 7 and you're going to press the button y to the power x, and then you're going to press 3 divided by 4, and then you're going to get the answer as 4.30. So I'm gonna box the answer just to make sure that we know what is the answer. 6, and you press the button y to the power x, and you're going to have now 2 divided by 5, and then your answer is going to be 2.05. So for the next one, you're going to divide it 1 over 64 to the power 1 over 3 times 2. You can solve it through, not through the calculator, by hand. 64 to the power 1 over 3 means cube root of 64, that is 4. 4 to the power 2 is 16. So 1 over 16 will give you the answer as 0.06. And for the next one, you're going to use 16 to the power 5 over 4. And again, you're going to press the button, this one, and then on the top you're going to press 5 divided by 4, or you can just simply do that as 16 to the power 1 over 4 to the power 5. Fourth root of 16 is 2, and 2 to the power 5 is 32. Solving equations using nth roots. To solve an equation of the form u to the power n equals d, where u is an algebraic expression, take the square root or nth root. So for example, if this is n, then we're going to take nth root of each side. So let's discuss example number 4, and we can see how we can apply this method to solve these type of equations. We are going to solve letter A. 4x to the power 5 equals 128. First step is always take care of the number before or after the variable. So here is my variable x to the power 5. I want to get rid of the 4 first, so I'm going to divide 4 on both sides, and I get x to the power 5 equals 32. Now I'm going to find the x value. It means I need to get rid of 5. Just think about it. If it is a square, then the opposite of a square is square root. If it's a fifth power, then opposite operation to get rid of fifth power is fifth root. So you can take both side, fifth root on both sides. So x to the power 5 and fifth root on both sides. Now what is mean by fifth root? We can see that there is a power 5. To cancel 5, you need 1 over 5. 1 over 5 is called fifth root. So that's why we call it as take fifth root on both sides. Now, taking fifth root on both sides, you can cancel the 5 on each side. So 5 and 5 cancel. You got x equals fifth root of 32 is 2. So the answer is 2. I'm using the other space to find the fifth root in a radical form. So if x to the power 5 equals 32, then take a fifth root on both sides. Since they are opposite of each other, so fifth root and exponent 5 cancel each other. So you got x equals fifth root of 32 is 2, so x equals 2. This is when you take a power as an exponent on both sides. This is when you take a radical form on both sides. Now if you want to solve for b, you're going to get rid of the 4 on the top. So this is a quantity x minus 3. You want to get it by itself. It means you need to get rid of 4. So which means that you're going to take a fourth root on both sides. So in this case, to cancel the power 4, we need to get the fourth root on both sides. And 4 and fourth root cancel. X minus 3 equals plus or minus fourth root of 21. Plus 3 on both sides, so plus 3 on both sides. You get x equals 3 plus or minus fourth root of 21. If you want to write this way, this is called the answer in a radical form, but we can make it into a decimal form. X equal 3 plus or minus. We are going to find the fourth root of 21 from the calculator. So in the calculator, you're going to put 21 and that symbol y to the power x button, and then you're going to press 1 over 4 because fourth root means to the power 1 over 4. And what I got from the calculator is 2.14. And what you're going to do now is you're going to have two answers. So one of the answer is x equals 3 plus 2.14, and that's going to be 5.14. So that's one of the answer. And other answer is 3 minus 2.14, and then that would be 0.86. So the two answers are there. Remember, whenever you have even power and inside you have even n, inside you have a positive, always write a plus or minus sign. Next is number 13. Divide 8 on both sides. X cube equals 64 divided by 8, and that's 8. Taking cube root on both sides, so into use cube you need a opposite of that is cube root. They cancel each other. Cube root of 8 is 2. Anytime we have n as odd number, we should have only one answer. In the next one, you're going to multiply 2 on both sides. 2 and 2 cancel. X to the power 5 equals 1024. To get rid of the 5, we need to take a fifth root on both sides. So fifth root on both sides. 5 and fifth root cancel. X equals one answer, and that is going to be, so if you multiply 4 to itself by 5 times, if you multiply 4 5 times to itself, you get 1024. It means that 4 is the fifth root of 1024. We have that also in the list that we created, where we have 1 cube is 1, 1 to the power 4 is 1, 2 to the power 4 is 16. There in the list, you can see that 1024 is 4 to the power 5. It means 4 is the fifth root of 1024. For number 15, you're going to take a fourth root on both sides. So we're going to get here 16, fourth root of 16. The 4 and fourth root cancel. X plus 5 equals plus or minus 2. Now you're going to subtract 5 on both sides. So you got x equals -5 plus or minus 2. When you have plus or minus 2, it means you're going to have two answers. One with the plus 2, that gives you -3. And one with the -2, and the answer for that would be -7. For the next one, you're going to take a cube root on both sides. Whenever we take a cube root, or fifth root or seventh root, we only have one answer. So cube root on both sides, cube and cube root cancel. You got x minus 2 equals cube root of -14 plus 2 on both sides. You got here is x equals 2 plus cube root of -14. Now we can find the -14 to the power 1/3 from the calculator. So we can put that into the calculator like this. So the answer for this one is going to be x equals approximately -0.41. Example number 5, real life applications. A hospital purchases an ultrasound machine for $50,000. The hospital expects the useful life of the machine to be 10 years, at which time its value will have depreciated to $8,000. The hospital uses the declining balances method for the depreciations. So the annual depreciation rate R in decimal form is given by the formula R equals 1 minus S over C to the power 1 over N. In the formula, N is the useful life of the item in years. So it means that it's going to be 10. S is the salvage value in dollars. So that means it is the salvage value 8,000. And C is the original cost. So remember, original cost was 50,000. So we have all that we need to find our annual rate of depreciation, that is R. So what do we have here is N, that's 10. We already discussed that number of years are 10. Depreciation value 8,000 and the cost was 50,000. We're going to write that into the formula. So 1 minus S divided by C. So S is 8,000 divided by C is 50,000 to the power 1 over 10. The number of 0 cancel, and what you got here is 1 minus 8 divided by 50. You can reduce it to 4 over 25 to the power 1 over 10. So we're going to solve this part from the calculator. So we're going to use it 4 divided by 25 to the power 1 over 10, and we're going to minus it from 1. 4 divided by 25 to the power 110, I got it from the calculator, 0.83. 1 minus 0.83 give me approximately 0.167 in decimal. So if you want to turn it into percentage, then you're going to multiply it by 100, and that becomes 16.7%.